Hi, I'm Casimir. I use they, them pronouns. I did a co-op at the University of Notre Dame Environmental Research Center in summer of 2021. That was last year, right? And I was a fellow, was my title, at UNDERC. And so it was a research program similar to a research engagement opportunity for undergraduates, which is REU is the acronym for that. There's a lot of acronyms. So it wasn't an REU because it was funded directly by Notre Dame, but it's functionally the same thing where undergraduates get to go to a place, work with a professor, do some sort of independent research, which is really important for a science student because you need to have some sort of independent research experience if you have any chance of getting into graduate school. So this was kind of key for me in my academic career at Antioch.
So what the heck did you even do at this fellowship? You just said a lot of cool words, but what did you do there?
So I lived at the Notre Dame Research Center on the border of Wisconsin and Michigan in the middle of the woods. It was pretty far out there. The closest town was 20 or 30 minutes away. The closest grocery store was an hour away. And we lived in a dorm, and we cooked our own food and that sort of thing. I got a stipend. I got paid, which was awesome. So I got $5,000 total over the course of the summer. It was $900 every other week. It was kind of insane. And then what I actually did was engage in research. So I did an independent research project centered around trees. It involved something referred to as allometry.
What is allometry?
Allometry is the relationship between different parts of a tree or different parts of an organism in terms of size. For trees, I was looking at the allometric relationship between the diameter of the tree at breast height, DBH, and the canopy, different canopy traits. So the canopy is where the leaves are and that sort of thing. So it's looking at the relationship between canopy traits and tree architecture. And it was an allometric relationship. And so it's pretty math oriented. It was a lot of modeling work, which may or may not be interesting depending on who you ask. But functionally what I was doing was I did a shit ton of field work in the first 6 of the 10 weeks, and then for the last 4 weeks I did a bunch of stats and a bunch of writing, so I produced an independent research paper by the end of the summer. And a lot of my field work was going out in the woods, walking into swamps and that sort of thing. It was really swampy, it was full of wetlands. The mosquitoes were the worst you've ever seen. It was actually terrible. A lot of my field work, I was wearing waders and walking into swamps and measuring trees.
What the heck is a waiter?
It's the guy who serves you at a restaurant. It's like rubber overalls, but they go all the way to your feet and contain boots. So you don't get soaking wet, but you still get wet because you sweat inside of the waders because they're airtight and no water gets out. But it's better than swamp water.
The lesser of two evils, I would say.
Yes, exactly. But so I would measure the trees with a diameter tape. It's like a tape measure. You wrap it around the tree. But also what was really fun is I got to use this thing. It's a laser, and it tells me how far away things are. And it's used to measure. It does trigonometry for me, so I don't have to do it myself. And it tells me how tall the tree is and where different parts of the tree are and that sort of thing. So that's how I got my canopy measurements. And so I went out for my field work and measured these 2 things. It was 12 things, but two things basically. And then I went home and would do all the data entry, and then we did statistics to determine whether there was a relationship, which there was. It'd be really weird if there wasn't, because this has been documented for decades. But the interesting thing, or the novel part of my research, was taking this model I created. The model was the relationship between the diameter of the tree and the crown traits, and applying this model to other trees using it in a predictive manner, which just means taking the diameter of other trees, plugging it into the model that I developed, and then getting predicted crown traits for those trees. So I only measured 150, 200 trees over the course of 6 weeks.
Only 150 to 200 trees.
It goes pretty quick. So the model is a relationship, and then it's predictive, and then we use the predicted canopy traits to then predict growth. So I only had 6 weeks to collect data, but in the past, people have measured trees, believe it or not, and they've measured how they've grown via their diameter. So my mentor, Dr. Nathan Swenson, who's a professor at Notre Dame, and he's a very prominent functional trait ecologist, which is a subfield of ecology. But yeah, so I used a data set that he had collected about 5 years earlier at a nearby national forest, and took the diameter data for those trees, because I had diameter data for 2009 and 2014, and that's 5 years, and thus the diameter grows over those 5 years, and I can get growth from that. and then I took the predicted traits and saw how it correlated with growth. Because when you look at a tree, the thing that makes it grow is the fact that it has leaves, and it can produce glucose via photosynthesis and that sort of thing. So theoretically, the thing that produces growth or that allows you to determine growth for a tree is a canopy trait. So if I can go and measure a tree, develop a model, and then apply that model to tens of thousands of trees, I don't have to measure all of those trees to know how much they're going to grow. So it did work, mostly. So I studied 5 species. 4 out of the 5 of my species were statistically significant, which just means the math was good enough that we determined it to be probably true. It was good both because I learned how to do a lot of different things and I had a lot of fun, and this is like what I enjoy doing, and also because I was able to then send this to professors and be like, hey, I want to work for you, I want to do a PhD, this is what I've done, this proves I'm capable of blah, 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 blah. So it's good for both my personal experience and also like building my CV and that sort of thing.
So you've talked a lot about how much you've learned, and it also sounds like you did some really cool research. So what ended up happening with the research, and what are you going to do with it next?
So I took the research and I'm actually using it for my senior project as well. So I graduated in the spring and I did some more measuring here. I measured maple trees here and maple trees in Wisconsin. I'm comparing the growth of the two, hopefully. So I have a little bit more math to do for that. So that's how I'm extending this project after it's done. And I'm working with a different Notre Dame professor, Dr. Jason McLaughlin. So I don't know if this is ever going to get used again. Probably won't get published because to publish it, it would need, I don't know, probably like 5-10 more species of tree measure. It would be another summer's worth of work, basically, which I don't have. It's probably the only reason I was able to do a PhD program. If I hadn't done independent research of some kind, like rigorous independent research, rigorous for an undergraduate, I would have nothing that would prove that I'm capable of doing independent research, which you have to be able to do for a PhD. A lot of ecologists still do a master's and then a PhD because a master's is a lot easier to get into, which I'm not doing.
If you could go back to yourself before you went on this co-op, do you have any advice for yourself?
It was honestly exactly what I expected. So socially, it was weird. That was kind of the only downside, was that these people are not my people in a lot of ways.
How did you cope with them not being your people?
I'm not very social in the first place, so it wasn't that big of a deal. I had a friend, which was nice. Talked to my friends at home. It wasn't really that big of a deal for me.
Do you have any advice for other people who might be looking to do either a PhD, like right after coming to Antioch, or who might just be interested in applying to these more rigorous programs?
This is general co-op advice, but you should do the scary thing. People are cowards about co-op, yes! Honestly.
Do the big thing.
People need to leave campus and go do weird shit somewhere. And if it's productive weird shit, that's even better. Advice you just need to get a research program somewhere and do independent research. And REU is the best opportunity, or Notre Dame's thing is the best opportunity. But even, I don't know, working with somebody at Wright State or something, or somebody who has a research lab is really important.
Would you say that your advisor here was helpful in finding this and helping you get into this program?
Yeah, my parents didn't. I think my mom has a bachelor's, but she's a nurse. My grandparents were farmers, so I don't know anything about academia. And my advisor has been extremely helpful in navigating the bureaucracy of academia, and that also she just knows people.
Do you feel like there's anything else that we've left out?
No, you're the person doing the interview.
I'm amazing at this.